Today is our lecture number 25, chapter 2, Differentiation, and today inshallah we will cover this topic, increasing and decreasing function, and the related exercise also. Now we start our lecture. Now first I would like you to tell you what is the geometrical interpretation of derivatives. Now usually we say that the slope of the tangent line to the graph of the function, sorry, to the graph of the function f of x at point, let's say it's the point has 2 points and the points are x1, y1, is the derivative of f of x at p of x1, y1, and that is slope of tangent at p is equals to dy by dx at the point x1, y1, and this is known as f prime of x1. Now how we explain it through graph? Let's say we have this curve which is the graph of the function of f of x. This is the function and this curve is the graph of this function at points p1 and x1. Now the derivative of the function at these points is like a line which just the slope of the tangent line. This slope of the tangent line at and when it touch at a point what p of x1, y1. This representation, this graphical, this geometrical representation shows that this is the geometrical interpretation of the derivative at specific points. Now today we will discuss increasing and decreasing function. Now first I will show you the definitions of these two topics. Now here we have increasing and decreasing function of your book at page number 104. You can open your book and kindly see this topic. Here we have increasing and decreasing function. Now let f be defined on an interval, this open interval AB. F is defined at this interval, and let's say these are the 2 points of this interval. This is like if I show you Now let's say we have a real line. Let's say we have a real line like this. Oh, this line is very okay. I will draw it again. This is a real line. Let's say we have this interval A and B. This interval A, B. And here we have 2 points. Let's say this point is x1 and this point is x2. And we say that x1 and x2 belongs to this interval. This is the interval AB, and these 2 points are in between this lies between this interval. Okay. Now FB defined on interval this AB, and these are the 2 points of this interval. So what happened? F is increasing on that interval AB if function at second point greater than the function at first point. What I'm saying, that increasing function, the function is increasing when f of x2 is greater than f of x1. When f of x2 is greater than f of x1, and the condition is whenever x2 is also greater than x1, and same thing is happened here. When we are moving from minus infinity to plus infinity, a is less than x1, x1 is less than x2, and x2 is less than this b, and so on. But here we are talking about this specific interval a, b, in which we have two different points. There are some more points, but here just to explain the increasing function, we have taken just 2 points which lies between these 2 points. So let's say these points are x1 and x2, and we say that these points are belong to this interval. And increasing function, when we call our function is increasing function, then what condition must be true? That the condition is the function at point x2 at this point must be greater than function at the second point. Whenever x2 is also greater than x1, then we say that our function is an increasing function. But when we say that our function is decreasing, so what will happen? The opposite thing will be happen. Our function f of x2 is greater than, not greater than, less than. Our function f of x2 is less than f of x1. But whenever x2 is also greater than, still greater than x1, but the condition will reverse. In increasing function, function f of x2 x1 is greater than f of x2, and the point x1 is less than x2. Sorry, this is not greater than, this is like this. F of x1 is less than f of x2, and the point is also less than, x1 is also less than x2. But in case of decreasing function, when we talk about the same condition, here we have x1, x2 and b, then f of x2 is less than f of x1. This function will be less than to this when x2 is still greater than x1, right? So these are the conditions which are required for increasing function and for decreasing function. So these are the proper definition. You can see f is increasing on interval a, b if the function at second point is greater than first point, function at first point, and whenever x1, x2 is x1 greater than x1, and this is obvious. Now f is decreasing when it is decreasing on that interval when function at x2 is less than function at x1 whenever x2 is greater than x1. Okay. Now we have a second thing, that is the theorem at page number 105. Here we have just the statement of theorem, and the theorem is f be differentiable. Let's say f is a differentiable function. Which function is differentiable function? Whose derivative exists. And here we say that f is a differentiable on the open interval a b. When f, let's say this function is differentiable on this interval, then if we check that the condition for the increasing function is true, right? When first check is that whether the function is increasing or decreasing. When we find the function is increasing, then we take its derivative. And if the derivative becomes greater than 0, greater than 0 means the function must be positive. Then we say that the function is what? The function is increasing function or decreasing. This is also known as first derivative test for the increasing and decreasing function. And if the opposite thing is happened means when we find the function is decreasing or increasing in a specific interval, and then when we take this first derivative which is also less than 0 means the derivative is negative, then we say that according to first derivative test it's the increasing function or decreasing function. I will explain it here. Okay, now see that this is called first derivative test. First derivative test for increasing and decreasing function. Now the first condition is that the function is increasing or decreasing means the function is f is increasing when increasing in on interval a b if its derivative is greater than 0, and f is decreasing on interval ab if its derivative is less than 0. Here we have for all x belongs to, means all point of this function belongs to this interval ab. Now some points are known as the stationary points. Stationary points. Stationary. So which points are known as stationary point? Any point where f is neither increasing nor decreasing. So such points are known as stationary points, which are neither increasing or nor decreasing functions. So those points are stationary points. Now we start our exercise, and you can see this exercise is at page number 113. Exercise page 113. So we started. Now we start our exercise. Exercise 2.9. The question number 1 is determine the interval in which f is increasing or decreasing. for the domain mentioned in each case. Now the first part is when f of x is equals to sine of x. Okay, we start its solution. Now when f of x is equals to sine of x and the given domain is minus pi to pi. Okay, so the first step is, step 1 is differentiate it. Differentiate with respect to x. So when we differentiate, we get f prime of x is equals to cos of x. Now we apply the first derivative test on this function. So before applying the derivative test, you see this. This is the first quadrant. This is second quadrant, third quadrant, and the fourth quadrant. The range of first quadrant is from 0 to pi by 2. Then from pi by 2 to minus pi. And then we have minus pi by 2. And this is 0, or we call it pi. Now, here we have some divisions of all trigonometric functions. In some quadrant, few trigonometric functions are positive, and in other quadrant, few trigonometric functions are negative. So how we decide it? Let's say we call it cast, a word cast. This will help you. This is not a rule. This is just a helping word through which we can decide on which function. Not decide, we just remember that how the function, which function is positive in specific quadrant, or which function is negative. So when we write cast, C-A-S-T, it means that in first quadrant, in this first quadrant, all functions are positive. All function means all 6 function: sine, cos, tan, secant, cosecant, and cotangent. Here we have S. S means sine is positive. Here we have T, means tangent is positive. And here we have C, means cos is positive in fourth quadrant. Okay. Now come to the question that we have to find whether function is increasing or decreasing. We have taken its derivative, and the step 2 is we check its increasing function. For increasing function, f for increasing function, the condition is our derivative must be greater than 0. So here we have our derivative is cos of x, so it must be greater than 0. So we have to find those quadrant in which our derivative is, means or in which our function is derivative, or cos of x is, sorry, means or cos of x is positive. Its means function, derivative of our function is positive. So it means that x belongs to in first quadrant and then to fourth quadrant, because in these two quadrants our function is positive, in first quadrant and in fourth quadrant. In these two In these two quadrants, our function is positive. So we can say that, so f is increasing on the interval minus pi by 2 to pi by 2, right? Now again, the step 3 is for decreasing function. Decreasing function. So what we will do for the decreasing function? The same thing. First, we apply the definition of decreasing function. The definition of decreasing function is that the derivative of our function must be less than 0. So here we have our derivative of function is cos of x. So we have to check on which quadrant, in which quadrants our function is less than 0. It is negative. So we see that our function is negative in second and third quadrant. So f is decreasing on the interval pi by 2 to pi, and then minus pi to minus pi by 2. So these two intervals, the second interval is started from pi by 2 to pi, and then the third interval is from minus pi to minus pi by 2. So this is the end of this is the whole solution of our function. So we again see how we have solved this question. In first step, what we have done, we have taken the derivative of our function. F of x is equals to sine of x, and the given interval is minus pi to plus pi. And then in step 2, we have checked whether the function is increasing. So we see that by applying the first derivative test, we have taken the derivative must be, according to the increasing function, the derivative must be greater than 0, means cos of x is derivative. So we check in which quadrants our function is positive. So we see that in first quadrant and in fourth quadrant our function is positive, or derivative of our function is positive. So we have decided that, so our function is increasing in minus pi by 2 is increasing function in the interval minus pi by 2 to pi by 2. And for decreasing function, we apply the definition that the derivative of the function is less than 0, means in our case cos of x is less than 0. And less than 0 means our function is negative. So we have checked that our function is negative in which quadrants. So in second and third quadrant our function is negative. So by using this theory, we have find the interval in which our function is decreasing. Now come to the second question, second part, that is f of x is equals to cos of. The same solution, so you can solve it by yourself. I will solve the third part, that is f of x is equals to 4 minus x square. So as the first step is the same step, step 1, we find its derivative, f prime of x is equals to 0 minus 2x. So we have 2x. The second derivative is 2x. So we apply the first derivative test. Now for increasing function, we apply the definition of increasing function, and increasing function, according to this increasing function, or derivative of our function must be greater than 0. So here we have 2x is derivative of our function, so 2x is must be greater than 0. Now it means x is minus x is greater than 0, or in other word x is less than 0, which implies that so we say that f is increasing in our function. In our question, the interval is also given, means f of x is equals to 4 minus x square for the interval what x belongs to -2 to 2. For this interval, our function is equals to 4 minus x square. Now when we apply the first derivative test, we say that f is increasing on the interval 0 less x is less than 0. So we say that this is the negative point. Here we have x is greater than this -2 and less than this 2. So -2 is less than 0. That's why you see here x is less than 0. X is less than 0 means instead of writing 2, we say that the f is increasing function for the interval -2 and 0. Now again here for decreasing function. Now for decreasing function, we apply the definition that derivative of function is less than 0. Here we have 2x is less than 0 means minus x is less than 0, or x is greater than 0 means f is decreasing on the interval. So how we decide this interval? X is greater than. So this point will be changed. 0 to 2. 0 to 2. For decreasing function, -2 to 0, and for increasing function from -2 to 0, and for decreasing, that is 0 to 2. So this is the solution of our question. Okay, this is fourth part is also a polynomial function, and you can solve it by yourself. I will start the question number 2. Before starting the question number 2, I will give you few concepts. Here we use the term that relative maxima and minima. Maxima means maximum, and minima is obviously a minimum value. So here we have two conditions. The first condition is that the function, if we have a function y is equals to f of x, and this function is said to have a relative maxima if f of c is greater than or equals to this function for all x belongs to c minus delta x and c plus delta x. for all delta x is greater than 0. I will show you by this figure. Let's say we have this x-axis and y-axis. Okay. This is a symmetrical graph. There is no curve. Okay. Now let's say uh, this is our 0 point, this is y-axis, and this is our x-axis. And here we have a point C. And when we go towards this left side, means we are moving towards the small point as compared to C. C minus delta x. Towards the origin, there is a small change in this point C, and we call this change C minus delta x. But when we move towards the right side of this C, it moving to the greater point, so some points are added in this C. This is like if we C is equals to, let's say, 4. When we go to this side, there must be some points. 4 minus 3, we are moving 3 points towards this left side, means we have 4 minus 3. Let's say the small changes, like small changes in point something, but just to explain you, I have taken this specific real number, means 4 minus 3, that is 1. This is the smaller side, and this is the side where we have those points which are greater than this C. So this is a C plus delta x, and this side is C minus delta x. If we have such type of a graph, then we say that this is a relative maxima. But if we have this type of graph, then this point show that relative minima. And the definition of relatively minima is a function y is if the function f of x, and we said it means this function is said to have a relatively minima at x is equals to c if function at that point is less than or equals to this original function, right? This is the function. If this original function become greater than this point, then we say that this is a relative minima. This point is relatively minima. But if this thing happened, means y is equals to f of x at some specific point, that the function at that point become greater than this f of x, then we have relative maxima, means another point other than this function. We have a such point at which the function become less than that point, then we say that we have a relative maxima. If the opposite thing has happened, then we say that we have a relatively minima. So these are the concept of relatively maxima and minima. Now you see this first derivative test. Why I have given you the concept of maxima and minima? Because here we have one more theorem, one more theorem, that is if f is differentiable in a neighborhood, means function is at some other point, or function is defined and differentiable at some point, but if f is differentiable in neighborhood of C is some other point where or derivative is equals to derivative at that point equals to 0, then what we say, the function has relatively maxima at that point if derivative is greater than 0, and before x is equals to c, or original derivative must be less than 0 after x is equals to c. I will explain it by solving this question from your book. Now you see this question number 2 of your book. Question number 2. Find the extreme values. Extreme values. Okay. Now f of x is 1 minus x cube. We differentiate it with respect to x. Means x prime of x is equals to minus 3x square. We again take its derivative. F double prime of x is equals to 6x minus 6x. Now, this is the first step, step 1. We have written this function. Then in step 2, we have find its two derivative, first derivative and second derivative. Then in step 3, these are the steps when we are going to find the extreme values. Now in step 3, what we will do in step 3, for extreme values, we put first derivative is equals to 0. And what is the first derivative? That is minus 3x square is equals to 0. And when we simplify it, we get x is equals to 0. Now we check this point f double prime of 0. We check this point x is equals to 0. The point is we apply in second derivative. This is the step 4. Use this point of x in second derivative. So f of 0 is equals to minus 6 of 0, means it is also equals to 0. When our second derivative is equals to 0, we say that second derivative, this is our first derivative test. When we are going to find the f prime of x is equals to 0, and then we apply this point on our second derivative, this is known as the second derivative test. So we say that second derivative test gives no information. Then we apply first derivative test. And what is first derivative test? As we have done in our previous question, we have applied the first derivative test, in which, according to first derivative, as f prime of x is less than 0 if x is greater than 0, and f prime of x is less than 0 if x is less than 0. So f has a point of inflection. Here we have the answer is 0, means we have no information from these two tests. So we say that there is no point of increasing and decreasing. F has a point of inflection at x is equals to 0. Now f of 0 is equals to, we applied this 0 in our original function. So 1 minus 0 cube, and that is equals to 1. So point of inflection is 0 and 1. When we apply 0, we get 1. So this is the independent variable and this is dependent. So 0 and 1. These are the point of inflections. Now I will give you the concept of, this is the question. Before I have before I will discuss the definition of first derivative test and second derivative test, I have solved this question. Now you can see the question number 2. F of x is equals to x square minus x minus 2. Again we do the first step, that is differentiate with respect to x. So f prime of x is equals to 2x minus 1 minus 0, and the second derivative of x is equals to just this x. So what we do, first we apply we say that for extreme value, what we will do, we write f prime of x is equals to 0, means 2x minus 1 is equals to 0 and x is equals to 1 by 2. Now what we will do, we use this point in our second derivative. Use this point of x in second derivative. So the second derivative is f double prime of x is equals to x, means f double prime of 1 by 2 is equals to 1 by 2. And this 1 by 2 is a positive number, so it is greater than 0. Then we say that our function has, this is a greater than 0, means this is a minima point or a maxima point. So when you see the definitions, I will repeat the definition. Function at point C is greater than or equals to the original function, then we say that we have a relative minima, a maxima. F of C is greater than or equals to f of x. Or in simple word, I will tell you in a simple word. First derivative test, I will explain it again. First derivative test, see, sorry, this is very untidy. First I will finish this question, then I will again explain you first and second derivative. So f has what we say, that f has a relative minima. Minima at x is equals to 1 by 2, and its value is, minimum value is f of 1 by 2. F of 1 by 2. So what was the function? Since f of x is equals to, I will again write the function, that is x cube minus x minus 2. You just apply this minimum value in our function. So f of 1 by 2 is 1 by 2 cube minus 1 by 2 minus 2, and when you calculate it, you will get minus 9 by 4. This is the result. So you see, there are some specific steps The first step is we have find its derivative. First derivative, then second derivative. And in next step, you will write first derivative is equals to 0 and get the value of x. And then you use that value of x in your second derivative and get some answer. If the answer of this second derivative is greater than 0, it means you have a function that has a relative minima at that point. And if that point, when you apply the point in your second derivative is less than 0, it means that f has a relative maximum at that point. And you just put that point back to your original function and get the answer of your function. I will again solve its third part for you. Now see third part of this. You can see the same steps. F of x is equals to 5x square minus 6x plus 2. First derivative, we find its first derivative, that is 10x minus 6. Now second derivative, that is 10x. What we do in next step, we put f of x is equals to 0. It means 10x minus 6 is equals to 0. And when we find the value of x, that is 6 by 10 means 3 by 5. Now in next step, what we will do, we use this value of x in our second derivative. You see, we have x is equals to 3 by 5. Use in second derivative. The second derivative was f double prime of x is equals to 10. So this is already a constant function. So when we apply 3 by 5, it will not affect our second derivative. And 10 is a positive number. So when it is a positive number, according to maxima and minima, relatively minima and maxima, when we decide it, we say that f has a relative minima at x is equals to 3 by 5. And what is the last step? We put this value in our original function. We know that f of x is equals to 5x square minus 6x plus 2. And when we put this value, we get 5 by 3 by 5 square, 6 into 3 by 5 plus 2. And when we calculate it, this will give me the answer 1 by 5. It means the minimum value of my function is 1 by 5. So these are the same steps which you will apply on all the rest of parts. And if you have any problem, you can discuss with me on my WhatsApp number. And this is the end of